Welcome. This demonstration is brought to you by Digital Den. Traditional networking can be a challenging and complex task, requiring specialized skills, equipment, cabling, and intricate configurations. However, Amazon Virtual Private Cloud offers a simplified solution that abstracts away the complexity, making it easier to deploy secure private networks. In this demo, you will create your own virtual private cloud using Amazon Web Services. By following these steps, you will be able to manually deploy resources within your VPC. One crucial aspect of deploying critical business systems is ensuring high availability. In AWS, achieving high availability involves running services across multiple availability zones. To begin, in Task 1 you will manually create a new VPC that spans 2 availability zones, setting the foundation for a resilient infrastructure. Your VPC will serve as the foundation for your private network. The VPC allows you to isolate and control the networking environment for your resources. In Task 2, you will create public and private subnets in 2 availability zones. Subnets are logical divisions within your VPC that allow you to segment your network resources. In this step, you will create both public and private subnets, each residing in separate availability zones. Availability zones are distinct data centers within a given AWS region, offering redundancy and fault tolerance. In Task 3 you will create an Internet gateway and attach it to your VPC. An Internet gateway acts as a bridge between your VPC and the Internet. By attaching the Internet gateway to your VPC, you enable communication between your VPC and external networks, granting Internet access to resources within your public subnets. In Task 4, you will set up network address translation gateways in the public subnets. NAT gateways allow resources within your private subnets to establish outbound Internet connections while maintaining a secure and private network environment. By creating NAT gateways in both public subnets, you ensure high availability and fault tolerance. In Task 5, you will configure route tables. Route tables are used to control the traffic flow between subnets within your VPC. In this step, you will configure the route tables to ensure proper routing between public and private subnets, as well as to enable Internet access for resources within the public subnets. In Task 6, you will create a security group for your web server instance. Security groups act as virtual firewalls, controlling inbound and outbound traffic for your instances. Here, you will create a specific security group for your web server instance, which will allow you to define the rules governing network traffic to and from the instance. Finally, in Task 7 you will launch a web server instance within one of the public subnets to verify that your VPC is correctly configured. This will allow you to test connectivity and ensure that your networking setup is functioning as expected. Let's get started. You will begin by using Amazon VPC to create a new Virtual Private Cloud, or VPC. The VPC console provides a wizard that can automatically create several VPC architectures. However, you will create the VPC components manually for the purpose of learning. Navigate to the VPC console and, in the left navigation pane, choose your VPCs. A default VPC is provided so that you can launch resources as soon as you start using AWS. However, you will now create your own VPC. The VPC will have a classless inter-domain routing range of 10.0.0.016, which contains over 65,000 addresses. You will later divide the addresses into separate subnets. Choose Create VPC and choose VPC only. Name your VPC web server. For the IPv4 CIDR block, enter 10.0.0.016. Choose Create VPC. A message that you successfully created the VPC appears. In the lower half of the page, choose the Tags tab. Tags are useful for identifying resources. For example, you can use a tag to identify cost centers or different environments, such as development, test, or production. Next, assign a friendly domain name system name to EC2 instances in the VPC. Choose Actions and select Edit VPC Settings. Select Enable DNS Hostname, and then choose Save. Any EC2 instances that are launched into the VPC will now automatically receive a DNS hostname. You can also add a more meaningful DNS name by using Amazon Route 53. In Task 2 you will create subnets. You will create 2 public subnets and 2 private subnets. A subnet is a subrange of IP addresses in the VPC. AWS resources can be launched into a specified subnet. Use a public subnet for resources that must be connected to the Internet, and use a private subnet for resources that must remain isolated from the Internet. Start by creating public subnet 1. This public subnet will be used for Internet-facing resources. In the left navigation pane, choose Subnets and then choose Filter by VPC. In the drop-down panel choose the web server VPC you just created. Choose Create Subnet. And for the VPC ID choose Web Server. For subnet name enter, Public Subnet 1. For availability zone, select the first availability zone in the list, which in my region is EU West 2A. For the IPv4 CIDR block, enter 10.0.0.024. Choose Create Subnet. You will now configure the subnet to automatically assign a public IP address for all instances that are launched in it. Select Public Subnet 1. Choose Actions and select Edit Subnet Settings. Then, select Enable Auto-Assign Public IPv4 Address. Choose Save. Though this subnet is named Public Subnet 1, it is not yet public. A public subnet must have an Internet gateway, which you attach in the next task. Next, create Private Subnet 1. The private subnet will be used for resources that must remain isolated from the Internet. Choose Create Subnet. And for the VPC ID choose Web Server. For subnet name enter, Private Subnet 1. For availability zone, select the first availability zone in the list, which in my region is EU West 2A. For the IPv4 CIDR block, enter 10.0.2.023. Choose Create Subnet. For high availability, you will create another public subnet in the second availability zone. Choose Create Subnet. And for the VPC ID choose Web Server. For subnet name enter, Public Subnet 2. For availability zone, select the second availability zone in the list, which in my region is EU West 2B. For the IPv4 CIDR block, enter 10.0.1.024. Choose Create Subnet. For high availability, you will create another private subnet in the second availability zone. Choose Create Subnet. And for the VPC ID choose Web Server. For subnet name enter, Private Subnet 2. For availability zone, select the second availability zone in the list, which in my region is EU West 2B. For the IPv4 CIDR block, enter 10.0.4.023. Choose Create Subnet. Your VPC now has 4 subnets. However, the public subnets are totally isolated and cannot communicate with resources outside the VPC. You will next configure the public subnets to connect to the Internet via an Internet gateway. In Task 3 you will create an Internet gateway. An Internet gateway is a horizontally scaled, redundant, and highly available VPC component. It allows communication between the instances in a VPC and the Internet. It imposes no availability risks or bandwidth constraints on network traffic. In this task, you will create an Internet gateway so that Internet traffic can access the public subnet. In the left navigation pane, choose Internet Gateways. Choose Create Internet Gateway and name it Web Server IGW. Choose Create Internet Gateway. You can now attach the Internet Gateway to your web server VPC. Choose Actions, then Attach to VPC. Under Available VPCs, place your cursor in the search box, then select Web Server. Choose Attach Internet Gateway. This action will attach the Internet Gateway to your web server VPC. Though you created an Internet Gateway and attached it to your VPC, you must also configure the public subnet route table so it uses the Internet Gateway, which you will do in the next task. In Task 4, you will create NAT gateways. You will create a NAT gateway in the first and second availability zone for high availability. A NAT gateway enables resources in the private subnets to connect to the Internet. A NAT gateway will allow instances that do not have a public IP address to access the Internet. In the left navigation pane, choose NAT Gateways. Choose Create NAT Gateway and name it NAT Gateway 01. For subnet name, select Public Subnet 1. For Elastic IP Allocation ID, select Allocate Elastic IP. Choose Create NAT Gateway. Next, create a NAT gateway in the second availability zone. Choose Create NAT Gateway and name it NAT Gateway 02. For subnet name, select Public Subnet 2. For Elastic IP Allocation ID, select Allocate Elastic IP. Choose Create NAT Gateway. By creating NAT gateways in both public subnets, you ensure high availability and fault tolerance. In Task 5, you will configure route tables. A route table contains a set of rules, called routes, that are used to determine where network traffic is directed. Each subnet in a VPC must be associated with a route table because the table controls the routing for the subnet. A subnet can only be associated with one route table at a time, but you can associate multiple subnets with the same route table. To use an Internet gateway, a subnet's route table must contain a route that directs Internet-bound traffic to the Internet gateway. If a subnet is associated with a route table that has a route to an Internet gateway, it is known as a public subnet. In this task, you will create a public route table for Internet-bound traffic. Add a route to the route table to direct Internet-bound traffic to the Internet gateway. Associate the public subnet with the new route table. Configure the network to send Internet-bound traffic from instances in private subnets to the NAT gateway. And finally, associate the private subnets with their route tables. In the left navigation pane, choose Route Tables. There is only one route table associated with Web Server VPC. This route table routes traffic locally, so it is called a private route table. Scroll to the right so that you can see the VPC column, then expand the width of the column so that you can see which one is used by Web Server VPC. Scroll back to the left and select the route table that shows Web Server VPC. In the name column, choose then enter the name Private Route Table 1. In the lower half of the page, choose the Routes tab. There is only one route. It shows that all traffic that is destined for 10.0.0.016, which is the range of the Web Server VPC, will be routed locally. This route allows all subnets in a VPC to communicate with each other. You will now configure the network to send internet-bound traffic from instances in private subnet 1 to the NAT gateway. In the Routes tab, choose Edit Routes. Choose Add Route and for destination enter 0.0.0.00. For target, select NAT gateway and then, from the list, select NAT gateway 01. Choose Save Changes. Next, create private route table 2 so you then can configure the network to send internet-bound traffic from instances in private subnet 2 to the NAT gateway 02. Choose Create Route Table and name private route table 2. For VPC, select Web Server. Choose Create Route Table. Next, configure the network to send internet-bound traffic from instances in private subnet 2 to the NAT gateway. In the Routes tab, choose Edit Routes. Choose Add Route and for destination enter 0.0.0.00. For target, select NAT gateway and then, from the list, select NAT gateway 02. Choose Save Changes. The next step is to associate the private route tables with the private subnets. By associating a private route table with a private subnet, you ensure that the subnet's traffic is directed according to the rules defined in that specific route table. Choose the Subnet Associations tab in Private Route Table 2. Choose Edit Subnet Associations. Select the row with Private Subnet 2. Choose Save Associations. Next, select the Private Route Table 1, and choose the Subnet Associations tab and choose Edit Subnet Associations. Select the row with Private Subnet 1. Choose Save Associations. You will now create a new public route table to send public traffic to the Internet gateway. Choose Create Route Table and for name enter Public Route Table. For VPC select Web Server. Choose Create Route Table. In the Routes tab, choose Edit Routes. You will now add a route to direct internet-bound traffic, 0.0.0.00, to the Internet gateway. Choose Add Route and for destination enter 0.0.0.00. For target select Internet gateway and then, from the list, select Web Server IGW. Choose Save Changes. The final step is to associate this new route table with the public subnets. Choose the Subnet Associations tab. Choose Edit Subnet Associations. Select the rows with Public Subnet 1 and Public Subnet 2. Choose Save Associations. The public subnet is now public because it has a route table entry that sends traffic to the Internet via the Internet gateway. In Task 6, you will create a security group for the web server. A security group acts as a virtual firewall for instances to control inbound and outbound traffic. Security groups operate at the level of the elastic network interface for the instance. Security groups do not operate at the subnet level. Thus, each instance can have its own firewall that controls traffic. If you do not specify a particular security group at launch time, the instance is automatically assigned to the default security group for the VPC. In this task, you will create a security group that allows users to access your web server via HTTP. In the left navigation pane, choose Security Groups. Choose Create Security Group and for security group name enter Web Server SG. For description enter Allow HTTP traffic. For VPC, select the X to clear the default selection, then choose Web Server VPC. Scroll to the bottom and choose Create Security Group. Verify the Inbound Rules tab is selected below. The settings for inbound rules determine what traffic is permitted to reach the instance. You will configure it to permit HTTP traffic that comes from anywhere on the Internet, 0.0.0.00. Choose Edit Inbound Rules. Choose Add Rule and then for type choose HTTP. For source type, choose Anywhere IPv4. For description enter Allow Web Access. Choose Save Rules. You will use the web server SG in the next task. In task 7, you will launch a web server instance in a public subnet to test that your VPC is correctly configured. You will also confirm that you can access the EC2 instance from the Internet. Navigate to the EC2 console. From the Launch Instance menu, choose Launch Instance. Name your EC2 instance web server. In the list of available Quick Start AMIs, keep the default Amazon Linux selected. Also keep the specific default Amazon Linux 2023 AMI selected. In the Instance Type panel, keep the default T2.micro selected. From the Key Pair Name menu, select Proceed without key pair. This is not needed to test if the VPC is configured correctly. Next to Network Settings, choose Edit, and for Network select Web Server. For Subnet select Public Subnet 1. Under Security Groups, choose Select an existing security group. For Common Security Groups, select Web Server SG. In the Configure Storage section, keep the default settings. Scroll to the bottom of the page and then paste the user data script which can be found on my blog. The link to my blog can be found in the comments section below. When the instance launches, the script updates the system, installs Apache HTTP server, starts the server, enables automatic startup, and creates a basic Hello World web page. At the bottom of the summary panel on the right side of the screen, choose Launch Instance. You will see a success message. Choose the instance that you launched. Wait until the app server instance shows 2 of 2 checks passed in the status check column. This may take a few minutes. Choose the refresh icon at the top of the page every 30 seconds or so to more quickly become aware of the latest status of the instance. Next, select the web server instance. Copy the public IPv4 DNS value shown in the Details tab at the bottom of the page. Paste the IP address into your browser tab. If you configured the VPC correctly, the message Hello World should appear. Congratulations! You created a VPC with both public and private subnets in 2 availability zones. You set up internet connectivity, configured NAT gateways for high availability, defined routing rules, established security measures with security groups, and launched an instance to validate the configuration.